Okay, example 7, and there's some work to be done here since we've got quite a space here. But it says, show algebraically, using the alternate form of the derivative, why g of x is not differentiable at x equals 1. Okay, so here's what I'm going to do. I'm just going to kind of graph it a little bit here so we can take a look. X squared, all right, is going to look like that. And then when I get to 1, I'm supposed to switch to y equals x. Oh my gosh. So, hey, that looks pretty good. All right. So let's try using the alternate form of the derivative then to show that those two slopes, the slope coming from the left, all right, is not equal to the slope coming from the right. All right. And if that's the case, that explains the cusp and therefore why it's not differentiable. All right. So here we go. So the limit, all right, as x approaches 1 from the left of this particular function is going to be x squared minus. Let me go back. Let me back up. It is going to be that, but I want to show a little bit more. Show the proper notation. Okay, it's not wrong. It's just let's make it clear. Of f of x minus f of 1 over x minus 1. This is the alternate form of the derivative. All right, so this is then the limit as x approaches 1 from the left, and left or right, it won't matter, but that's what we're doing because the red one is to the left of 1. All right, so f of x is x squared minus f of 1 is 1. Okay, and then the bottom is x minus 1, and here we go. We've got algebra that we can do. All right, so we got the limit as x approaches 1 from the left. A numerator is x plus 1, x minus 1. All right, denominator is x minus 1. And as you know, and as you've seen, bye. And so left or right makes no difference. Substituting a 1 in, and after I've done that, it is 2. Okay, and now it says to do it for this function too, but that slope's going to be 1. All right, but anyway, but I'll show it though. What the heck? All right, so the limit, and by the way, this was g, not f, so sorry about that. 1 from the right of g, and these should be g's. Sorry. All right, so g of x, all right, minus, now this one's weird because it's g of 1, but they're the same, so it works out. G of 1 over x minus 1. All right, so this is the limit as x approaches 1 from the right, and g of x is x, and this is x minus 1, and so is the bottom. They cancel out completely. Yeah, and that's just a 1 over 1, also known as 1. So since those two are not equal to each other, since 2 is not equal to 1, we have a cusp here. And though f it does hit each other at the right spot, we get 1 for both of those, so it is continuous but not differentiable. All right, and so I guess I should really say, since the limit as x approaches 1 from the left of all of this, g of x minus g of 1 over x minus 1 is not equal to the limit. I know this is a bit of a pain. As x approaches 1 from the right, since that's the case, then g of x, g, is not differentiable at x equals 1.